Okay, so in section 5-6 we talk about dilations. The first example here, it is just an example. So it says to dilate a figure in the coordinate plane using the origin, that's right here, as the center of dilation, you multiply each of the coordinates by whatever your scale factor is, okay? So there's going to be a couple different kinds of problems, but these are the ones that we're going to work with today. So what I'm showing you is if they want the scale factor to be 2.5, it is going to make our shape bigger. And if these were the original coordinates, you take all of the coordinates times 2.5. And it looks kind of complicated when we do it ourselves. It will be easier to look at. But if you take 2 times 2.5, you get 5. 2 times 2.5, you get 5. So what you do is you go through all of the coordinates, you multiply them, and then you plot the new shape. Okay? So these are the types of problems we're going to be doing around the center of being the origin. So I'm going to show you this. So they have this little triangle plotted, and I'm just going to go through the coordinates here. A is 1, 2, B is 2, 0, and C is 3, 3. They have those noted right here for you. Okay? They told you that our scale factor is 2. What that means is that you're going to multiply by a 2. So right here is the original coordinates. Sometimes I don't even like to write them out because it gets kind of complicated. So we're just going to skip that part and we're just going to multiply because we can do this in our head. So what's 1 times 2? 2. What's 2 times 2? So notice I'm jumping right to the new shape. What's 2 times 2? 4. What's 0 times 2? 0. What's 3 times 2? And what's 3 times 2? Okay, so now what I'm going to do is I'm going to go to my graph and I'm going to plot these 3 points. So the first one is 2, 4, 4, 0, and 6, 6. And then I'm just going to use a straight edge so I can have a nice straight triangle. And what I want you guys to notice is that my triangle did not change shape. It did not change orientation. It basically looks like it shifted and it got bigger. You notice that? Okay, so that is what you would call a dilation, using the origin as a center. Okay. So when the scale factor is a fraction between 0 and 1, the image is going to get smaller. Okay? Because basically what you're doing is you're producing a shape that's like this is 1/3 the size of the original. So on this one is done for us. 3 times a third is 1. 3 times a third is 1. 6 times a third is 2. 0 times a third is 0. 6 times a third is 2, and 6 times a third is also 2. And then the new shape has these little tick marks here, and I guess that's what we should have done here. This would be A, tick mark, C, tick mark, B, tick mark. That little mark, that comma, or apostrophe as you call it, would be, it shows that that's the new shape, that's the dilated shape. So this is the new shape. Okay, so now we're going to do one with a fraction right here. And notice that all of our coordinates are nice numbers. They're all even numbers, which makes multiplying by a half a little bit easier for us. So I'm going to jump right. I'm going to kind of skip the middle part because I actually think it's easier if you don't write it all out, okay? So that doesn't, I don't say that very often. So what's 8 times a half? 4. 0 times a half?
2.
Nope, it's just 0 times a half is 0.
Everything times 0 is 0.
That's right, yep. 4 times a half
2
is 2. 4 times a half
2
is 2. 6 times a half
3
3. And 8 times a half is 4. So then I'm going to go to my grid and I'm going to plot this. So A is 4, 0. So over 4, stays on the grid, or on the line. 2, 2. That's my B. And my C is 3, 4. Okay, and so then what you're going to do is you are going to make your triangle. And notice how it's smaller, but still relatively the same size, and then it's in the same orientation. Okay. So this is your homework, and we're just going to talk about this really quick. On your homework, notice the first shape was like a trapezoid. Okay. Now, the only sides that you're going to worry about with a trapezoid are, well, you can look at the coordinates, or you can look at, sometimes you can look at the dimensions too. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then this is 4. So there's two different things that I want to point out here. First off, did it change at all?
No.
No. Okay. And then second off, if it didn't change at all, if we really didn't multiply it, how did it just move on the coordinate grid?
Yeah.
Okay. This does not qualify as a dilation. Okay. So some of them, you can just look at them and figure it out. Now this one, you should double check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's a 6 by 6. And then what happened here? 1, 2, 3. 1, 2, 3. Yes. Okay. So those ones are just looking at. Now these ones are just like we did in our warm-up. So I'm going to start you on one, and then I'm going to let you guys get to work. So I think the best way to do this is to list the original coordinates. So A is -2, +2. B is 2, 2. C is 2, -1. And D is -1, -1. What does it want us to multiply this one by? 2. So when you create this, you are creating a new shape. You're going to multiply all those coordinates by a 2. Okay, so I'm kind of setting it up for you, and I want you to try to do that one. And the same thing with number 4. And then you have 4 more problems on the back side, and that's it. Okay?